Welcome back. In this video, we are going to look at some more compositions. In this case, we've got different variables. Instead of F and G or H and K, we have P and C. And you'll notice my independent variable instead of X, it is T. It's T for both of them. So C of T is 1 over T minus 5. And P of T is 2 over the quantity 7 minus T. We are asked to find C of P of T as well as the domain. So what this means, remember, the second function is always going to plug into the first function. So in this situation, that means P of T, which is equal to 2 over the quantity 7 minus T, we are going to plug that into C of T wherever there's a T value. So it's going to go in right there. That's what the notation means. So C of the function, C composed of the function P of T, that looks like 1 over, and for T, I'm going to plug in my P of T function, which is 2 over 7 minus T, and then we'll say minus 5. So if you get to this step, you understand what the composition should look like. Now, we just have to worry about simplifying this rational expression. And we have a fraction with a fraction inside of it. So this can get a little bit complex, but take a moment, pause, make sure you understand how I turned this notation into this new expression. 1 over the quantity 2 divided by 7 minus T, all of that then minus 5, which is all in the denominator. All right, so now let's look at simplifying. And here we're simplifying. We have fractions that we need to deal with. So remember, when you're dealing with fractions, you often need a common denominator. And what I'm going to do is I'm going to look at the fact that I have 7 minus T in the denominator. That 5 we're looking at, well, that's kind of over an invisible 1 right now. So what I'm going to do is I'm going to take the numerator and I'm going to multiply that by 7 minus T. Now we're not allowed to just multiply by any number. So if I put that over itself and say 7 minus T over 7 minus T, I'm multiplying by a fraction that's equal to 1. And that's perfectly legal. So what that ends up giving me is I end up with, in the numerator, 7 minus T. In the denominator, well, we have some distribution. 7 minus T, when I take that and I multiply it by this first fraction, that's going to cancel out the denominator and I'm left with 2. And then I'll have minus 5, and that 5 is now multiplied by 7 minus T. All right, so from here, all we need to do is a little bit of simplifying. That is 7 minus T over 2 minus 35 plus 5T, or rather 7 minus T over 5T minus 33. So that is C of P of T. That is our composition of two rational expressions. So I'm going to clean up this screen a little bit. So what you can see here, this is the composition function that we just found. So now we need to look at the domain. And of course, when we look at the domain, we always look at the resulting function. But we also need to look at the function that went inside. In this case, the function that was plugged inside the other function was P of T. So if we come over here and we say, well, what is the domain of P? Well, do we have a denominator or do we have an even root? And we have a denominator. What we know about the denominator is that 7 minus T, which we have in the denominator, that cannot equal 0. Simplifying, that means that 7 cannot equal T, or rather T cannot equal 7. So we need to intersect that domain with the domain of the function that we're looking at here. So if we look at the domain of C of P, here you can see the domain of the result. We have a denominator, and in this situation we have 5t minus 33 cannot equal 0. So if we look at solving this, that's going to be that 5t cannot equal 33, or t cannot equal 33 over 5. Now 33 over 5, that is 6 3/5, or rather 6.6. So we know that t is not allowed to equal 7 or this fractional value, 33 over 5, which is also the same as 6.6. So we have to leave out two values. That means the domain for C of P is going to be any t value such that we go from negative infinity to 33 over 5, union 33 over 5 to 7, union 7 to positive infinity. That would be our end result there for finding the domain. As always, feel free to email me if you have any questions or concerns. Good luck out there.